Neural networks, how much do you know? For me, I found I didn't know as much as I thought I did, so I wanted to go off and try and make my own. I had initially planned an idea of training a vehicle on wall avoidance and getting tanks to shoot each other. You're currently watching an iteration of that. These guys have been running for about maybe 2 minutes, and they're obviously getting better from my point of view. Initially, they weren't moving at all. Now, I got two other projects to show you after this that blew me away in how well it actually carried out the tasks of learning. But as you can see here, they've already begun shooting either at each other or uh, avoiding obstacles, which is what they're supposed to do. I've currently got this set on uh, the avoid obstacles training, but they can actually compete against one another. So I can set this up as a duel. Now, if I leave this running on auto training for a while, or I can take tank number 7 here, and I can drive it around myself, and I can teach it manually how to actually learn. I didn't find that I had a lot of success in learning from this project alone. I kind of jumped in a bit too fast because I knew enough to be dangerous, but I didn't know enough as to why I was being dangerous. So I want to show you how I decided to restart the project and then move on to making the next project. And I'm going to put these projects up online and you can have a look, but I would like to do that after getting maybe 20 likes on the channel. So multi-round evaluation is not the thing I'm going to show you next, but they will just keep on training and training and training, and they will avoid the walls, they'll shoot at each other, and they'll do many different things all by themselves without being pre-programmed in the first place. So the purpose of a neural net is to be able to do something that is not so easily described with certain sets of rules. So the neural net itself ends up producing internal rules based on weights to carry out tasks. So for example, go along any obstacle course. If you were just programming it, you would just say, hey, in 1 meter, turn left a little bit and then drive as fast as you can. Then 10 meters, turn right and drive as fast as you can, or slow down around the corner. You would programmatically put down everything on that one map, and you'd probably get it perfect. But if the map changed at all, then then you would crash or your vehicle would be destroyed. Whereas if you let a neural net learn, then it should be able to adapt to lots of different situations. So in this situation here, I can actually save the brain having gone through the 5 levels of training that I set up in the training hub. So you got wall avoidance, target dummy, hazard course, duel, and multi-round evaluation. And I have these other brains saved from previous lead. Now, I believe that I had shown something more advanced here, but I guess not. So I will just go and start up the other project. So right now I've got a spaceship called Space Rogue. Do I call it Space Rogue? Yeah, Space Dodger. And its job is to go through this maze of asteroids. It's come up with a unique pattern for itself, which I didn't expect, which was it drives forward and then it reaches a checkpoint, which is the entire width of this map going across, let's say over here. Each one of these lines is a checkpoint. I think that I spent the first 150 attempts just circling around here at the beginning. Here you can see it going through. But what it discovered for itself was as it passed a checkpoint, it should shoot in front of it to get rid of any asteroids. Now, I would give it a complicated challenge here because the asteroids move, it's random each time. Oh, and yeah, you can see its neural network that it's built up here at the bottom over that time period. So it goes through a checkpoint, it shoots everything else around it, and then it drives again forward. and it isn't trying to beat its time as it goes through, but it is trying to successfully get across a random map. Now, I have an extra challenge for it here as well, where I can start turning on enemy ships, which it hasn't had to face before. So, and then there's these little red mines. But I find it quite fascinating that it's, oh, by the way, the enemy ships are not neural networks. Now, if we go down to this neural network here, you can see that there's these, maybe hard to see. You got far left ray, far right ray, high ray, low ray. What I did is I've set up 6 different engines, an engine on the right, an engine on the left. So when the engine on the right goes, because then the ship will move left. If the engine on the front goes, then the ship will move backwards. But I didn't want to just use this for just one scenario. What I wanted to do, I think this, oh yeah, save network, go back, is I wanted to build this neural net dynamically. So what would happen if I changed the directions of the neural net itself, or the inputs. So it was hard. I tried to copy a little bit of Kerbal Space Program so it could see further to its own left and right. And yeah, the high ray was more centralized. Yeah, so then this would be saved. Save network. Where did I have this? Save network, it's already done. Save ship design. Oh yeah. Okay, but I can also add in, oh, I didn't want to do that. Remove hidden layer. Okay, so add ray sensor. So I got another ray sensor over here. It's just been added to the network. And its inputs, so that one is ray 8, as you can see there. And I can format the brain itself, but I really don't want to because I spent such a long time making it. Or I can delete the ray down here, and I can go back and go into Space Dodger, and you can see now it's got a sensor on the back. And if I started it off running, the back sensor shouldn't really affect it so much. Or the well, 1, it's behind it, and 2, it's a new sensor. And I think I have to actually set up the connection between there, which you can do from that neural network menu. However, I kind of skipped what I wanted to go through. This was meant to be the penultimate example, but previously I was working on a simpler neural tank. So let me explain the neural tank a little bit. You've got 4 separate layers. In this case, you can have the leftmost layer, which is the position of a checkpoint, its left and right arrays, all the different inputs that are brought into the system. Now you have 2 hidden layers, and then the output, and the outputs are going to control whether or not it fires the tank, or it uses the left motor or right motor. Very simple outputs. But the depth of the layers, first of all, means that you need a lot more training than if you just had one hidden layer. But what it does is it allows combinations of combinations. So it might say, oh, I can see the thing to the left, or if I interpret the neural net, if I can see the thing to the left, I can drive, and I can drive forward. Whereas it still gets a little bit of information from, say, there is nothing to my right, and I can drive forward. So the 2 pieces of a combination of information goes into the next hidden layer, and in the next hidden layer, it will use both of those to make the decision of what will go on the final output. So it's better if we see it in action. So let's go and see the racetrack. So I got a racetrack here, and I can actually, before I move on, let's say track builder. I thought this is pretty cool. We can build our own track, so it's different this time. We put obstacles in different places, and we can allow the neural network to go off and figure out the rules for itself. Yeah, okay. So now we can drive it here. I think before I put it online, I will actually make things a lot simpler for everybody to use, because I'm finding myself, having worked in the Space Dodger one to be for a while that I'm losing where I am located. So I know I can just race from here, clear track, new track, race on track. Okay, so let's go. So this one, I don't think it actually has a good neural network right now. It's attempt 1. You'll see it learn as we go by. If it spends too long outside here, it will die. And this guy is just set as a pre-programmed bot. As you can see, he's told to go shoot this guy, and he drives to his location to shoot at him. If something's in his way, he will shoot. So he's not. This is what a statically programmed AI is like. Whereas you can see already the neural network is learning about what is around it and is adapting and getting further along the track each time. As time progresses, and you can see here on the right hand side, you can see the neural network is changing. Red being negative and blue being positive. And these positive and negatives are between 0 and 1. Oh, sorry, -1 and 1. So it's not negative and positive like a good versus bad. A negative weight might actually be a positive thing for the left motor, and it could still also be a positive thing for the right motor, depending on where it is in the network. As you saw, it just got around the entire thing. It's about to die from until it gets to the checkpoint. The other tank is dead already, and we're about to die, and then it'll. So that lap time was. Oh, it still hasn't gotten around yet. Hasn't died yet. Around 64 seconds to get around. Okay, still going. So yeah, within only a short space of time, this small neural network has figured out how to get around this very simple map. It's not doing a great job of it, but initially it just drove into a wall. So, and that was only 3 or 4 attempts. And I think this might be because it's using a brain that I used before. So let's just start off with a different brain instead. Okay, so build neural network, and let's just reset the weights. So I can build a new network, new tank network 2, or Engo. Okay, and we've got only one hidden layer in between, and we will run this one now. I think race on track is there. No, it's not there. Okay, race on track. This uses the much smaller neural network, so it should learn quickly, but as you can see, it's driving backwards. It's not going to reach the next checkpoint at all, and it's going to die pretty quickly, and this other pre-programmed tank might actually shoot it. I don't know. But if I leave this, the other one I must have run maybe 30 or 40 times before I realized what it should be doing. But as you can see over here on the right, the neural network is beginning to learn as time goes on. I really don't want to sit here for ages showing you how the how long it took the Space Dodger one to work. So I recorded a video for you to see. I think, which I showed you earlier. Let's have a look. Yep. So this was it, just bobbing back left and right. Being crazy, and I was thinking this doesn't work at all. Kept on running up to the roof. This is attempt 28. If we go to a later one, attempt 30, and I think attempt 73, attempt 116, just floating up to the roof. I swear it never got past this line. It was driving me crazy, and when it got past it the first time, it was like, yes, it's finally understood that I should go to checkpoints. It didn't improve. So here's another one. Took a long time still, but I think, yeah, it got past the first checkpoint. You see it there, and it stayed in this hole for 400 and up at 400 something checkpoints. So now at 480, I think it is, I realized, hey, I can go forward and I can dive into things. And for a while I just thought I was making an asteroid shooter game where I was blasting every asteroid around it. And you can see how complicated the neural network is versus, let's say, go back again. There's not a lot of rules that it has learned or activations that are occurring. So added to all of this, in the last place, he's still driving backwards. I have an explanatory tool to explain the weights, and what would happen if you have different sensors affecting each weight and whether or not it should turn right or should it turn left. Because, maybe both of them can be activated at the same time in a positive direction and the car can just drive as fast as it wants. So that's what's happening, say, in this instance. So current speed, now it's going to be going more right at its highest speed. So this explanatory video comes with the actual networks, and you can see all the ones that I had previously saved personally, and you can go off and make your own networks from that. And I hope you enjoy. Remember, 20 likes and 20 minutes of watch time on the video would be greatly appreciated, because YouTube doesn't seem to like me.